This is Notebook Learnings. Every video on this channel is one complete project. Deep explanations, real code, and a fully runnable notebook you can download. Today we are building an ATS resume scorer and rewriter. Paste your resume and a job description. Get a match score, a list of gaps, and rewritten bullet points, automatically. By the end you will understand every layer of how it works. And the complete notebook is free, link in the description. Let us get into it. You spent 2 hours on your resume. You applied to 15 companies. You got 0 callbacks. By the end of this video, you will know exactly why, and how to fix it. Paste your resume and a job description into this notebook. You get a match score, the specific skills and keywords you are missing. And every week bullet point rewritten to pass the ATS filter. Complete notebook is free, link in the description. Here is the problem most job seekers do not know about. Before a human reads your resume, a bot does. ATS, Applicant Tracking System. It scans for keywords from the job description. If your resume does not match, it gets filtered out. The hiring manager never sees it. We fix that. In one notebook. The bot reads your resume and the job description. It scores the match. It finds the gaps. Then it rewrites your weak bullets using language from the job description itself. Everything here is real running code. Open the notebook, follow along, run every cell yourself. That is how this channel works. Let us get into it. A real ATS scanner does keyword matching. Our bot does something smarter. It asks an LLM to reason about the match, not just count words. That means it understands that Python and programming are related. A pure keyword counter misses that. 3 stages. Parse. Score. Rewrite. First we extract clean text from the resume. Then the LLM scores the match and identifies gaps. Then it rewrites each weak bullet using language from the job description. Structured output, not a wall of text. The install is straightforward, 3 package groups. Lang chain for the pipeline, pdfplumber for PDF parsing, and your LLM provider. We saw pdfplumber in the PDF chatbot project. It is back here for the same reason, reliable text extraction with page metadata. We also pin numpy before pandas to avoid the binary incompatibility. That affects Python 3.11 on Windows. If you ran the previous project you already have these installed. Run the cell anyway to make sure everything is on the right version. 2 steps, numpy first, then everything else. This order matters on Python 3.11 Windows. Pinning numpy before pandas prevents the binary incompatibility error. Run this cell once, restart the kernel, then continue. pdfplumber is the same library we used in the PDF chatbot. If you built that project first, you already know why we prefer it over pypdf2. Now the imports. 3 things worth noting here. First, pdfplumber for PDF parsing. Same as project 1. Second, JSON from the standard library. We will ask the LLM to return structured JSON and parse it programmatically. That gives us a clean dict instead of a wall of text. Third, for a small amount of text cleaning. The LLM sometimes wraps JSON in markdown code fences. A regex strips those before we parse. 3 providers, 1 flag, same pattern as the previous project. Groq is the default because this notebook works well on Llama 3.3-70 bytes versatile. ATS scoring and bullet rewriting are reasoning tasks, not factual recall tasks. The 70 bytes model handles both cleanly for free. If you need the highest quality rewrites, flip to Claude. Especially for senior roles where the language needs to be precise. With the LLM configured, we need something to score. Both resume and job description are bundled directly in the notebook. No files to download. Just run the cell. The sample resume is a mid-level Python developer applying for a Gen AI role. Intentionally imperfect, vague bullets, missing keywords. The job description requires LangChain, RAG, and vector databases. Some of those appear in the resume. Some do not. That gap is exactly what the scorer is going to find. The sample resume and job description, hard-coded as strings. This is deliberate. It means you can run this notebook top to bottom with zero setup. To use your own resume, replace sample resume with your text. To use a PDF, we build that parser in the next section. The job description goes in sample JD. Notice the resume has some vague bullets like worked on ML models. That is the kind of line an ATS filters out. The rewriter will turn it into something specific and keyword-rich. Sample data ready. Now let us build the input layer. The scorer handles two formats, plain text and PDF. We used pdfplumber in the PDF chatbot to extract page-level text. Here we use it differently, concatenate all pages into one clean string. No page metadata. Just raw resume text. One function handles both cases and routes automatically. The rest of the pipeline always sees plain text, regardless of input format. The parse resume function. It takes either a file path or a raw string. If it is a path that exists, it opens the PDF and extracts text page by page. We filter out empty pages, some PDFs have blank separator pages. Then, we join everything with a new line and strip excess whitespace. If it is already a string, we just clean the whitespace and return it. The output is always the same shape, a clean plain text string. Everything downstream works on that string regardless of where it came from. Resume parsed. Now the first LLM call, scoring and gap analysis. We ask the LLM to return JSON, not prose. Prose is hard to work with programmatically. JSON gives us a score as a number and missing skills as a list. We tell the LLM the exact schema, score, matched, missing, weak bullets. We also include the anti-hallucination instruction. Only flag skills that are genuinely absent. That one line prevents the most common failure mode in scoring prompts. The scoring prompt and chain. Notice the JSON schema is spelled out explicitly in the prompt. Key names, value types, what each list should contain. The more specific we are about the output format, the more reliably the LLM follows it. We also include the anti-hallucination instruction, only flag genuinely absent skills. The parse JSON response function handles one common LLM output problem. The model sometimes wraps JSON in a markdown code fence. The regex strips that before parsing. Without this, JSON loads raises an error and the whole pipeline breaks. Let us run the first LLM call, score and gap analysis. We pass the parsed resume and the job description to the chain. The raw output comes back as a string. We parse it to a Python dict. Then, we print the score and the three lists. Watch the score. Watch the missing skills list. Those missing items are exactly what the next stage is going to fix. Score and gaps in hand. Now the part that gets people callbacks. The rewriter takes each weak bullet and rewrites it using JD language. Not an invented bullet, a rewrite of what already exists. The candidate did the work. We express it better. 2 constraints keep this honest. First, grounded in the original. No inventing experience. Second, specific keywords from the JD, not generic power words. That specificity is the difference between a rewrite that helps and one that sounds like every other resume. The rewriter prompt and chain. 2 constraints in the prompt, grounded and specific. Grounded means rewrite what exists, do not invent. Specific means use actual keywords from the JD, not filler words. Notice we ask for just the bullet text, no explanation, no numbering. Clean output we can display directly. We run this in a loop over every weak bullet the scorer identified. Each bullet gets its own LLM call. That is more API calls than one batch call, but it gives better results. One focused rewrite per bullet beats a batch that loses context. Now, we run the rewriter on every weak bullet the scorer found. Each bullet gets its own focused LLM call. We print the original and the rewrite side by side. Look at the difference in specificity. The original is generic, worked on, helped with, did some. The rewrite uses keywords from the JD, RAG, lang chain, specific outcomes. That is the difference between a resume that gets filtered out and one that lands in front of a human. All 3 stages working. Now, we wrap them into a single class. Same reason as the previous 2 projects. Functions in notebook cells cannot be imported into an app. A class with a clean interface can. The constructor takes the provider, sets everything up internally. The score method runs all 3 stages and returns one structured dict. Pass in a resume. Get back a complete report. Wire it to Streamlit, Fast API, or Gradio, no changes needed. The full ATSScorer class. Notice the grade method, a small bonus. It converts the numeric score to a letter grade. A for 80 and above, B for 60 to 79, C for 40 to 59, D below 40. That makes the score more human-readable in a UI. 80 out of 100 is abstract. Grade A means the resume is strong enough to get past the ATS. Grade D means it needs significant work before applying. The score method runs all 3 stages sequentially. Parse, then score, and gap analysis, then rewrite. Everything comes back in one structured dict. The full end-to-end test using the ATSScorer class. 1 line to create it. 1 call to get the complete report. Then, we print everything, score, grade, matched skills, missing skills, and rewrites. Notice how clean the interface is. No chains visible. No prompts visible. No parsing logic. Just score. Score and a dict comes back. That is the interface you wire to a Gradio text box. Or a Streamlit upload widget, no changes needed. Let us take stock of what you actually built here. You understand how ATS systems work, and why keyword matching alone is not enough. You built a resume parser that handles both PDF and plain text input. You have a structured scoring prompt that returns JSON, not a wall of text. You have the anti-hallucination guard, missing skills are only flagged when genuinely absent. You built a bullet rewriter that is grounded in the original and keyword specific. And you have the ATSScorer class, drop it into any app and it works. The next project on this channel is the YouTube URL to study notes converter. Paste a YouTube link, get structured study notes, key questions, and a summary. The complete notebook for this project is free, link in the description. Start it on GitHub if it helps you land that interview. Subscribe so you do not miss the next one. See you there. The complete notebook is linked in the description. Sample resume and job description are bundled inside. Run top to bottom, no files to download, no setup beyond the API key. To use your own resume, replace sample resume with your text. For a PDF resume, pass the file path to Parse resume instead. All dependencies in requirements. TXT. Start it on GitHub if it saves you time.